Let's do problem 6.30 of Sonntag. So this is a problem which deals with control volumes. So we have nitrogen gas which is flowing into a convergent nozzle at 200 kilopascal and 400 Kelvin. So let us first draw a convergent nozzle. Okay. If it flows out of the nozzle at 100 kilopascal and 330 Kelvin, it is also given that the inlet velocity is very low. So at the inlet conditions we have pressure equal to 200 kilopascal, we have the temperature is equal to 400 Kelvin, and we have Vi, that is the velocity, let me denote it by capital V, is equal to 0. It is not equal to 0, but we can neglect it because it is given it is a very low velocity. The assumption here is that the inlet velocity, if it is low, the contributions towards the total enthalpy will be equal to 0. The nozzle is insulated. Okay, very good. Usually a nozzle is insulated. Because of this there is no heat transfer, and the exit state is given at 100 kilopascal, which is almost atmospheric pressure, and the temperature at the exit is given as 330 Kelvin. What is the exit velocity? Because there is only one inlet and one outlet, conservation of mass is trivial. Mi dot is equal to me dot. The first law tells me that in a steady state steady flow process, this is a steady state steady flow process, 0 is equal to q dot plus mi dot hi total minus me dot he total minus w dot. So this quantity is 0 because it is insulated. This quantity is 0 because there is no work extraction from a nozzle. Therefore, mi dot hi total is equal to me dot he total, because we only have this term and this term remaining, and everything else is equal to 0. And since we had proved mi dot equal to me dot, we have hi total equal to he total. Because the nozzle is a device in which there is no appreciable change in potential energy, the total contribution of the enthalpy, so hi total will be equal to hi plus vi square by 2 plus gzi. He total will be equal to he plus ve square by 2 plus gze. Now because the potential energy the changes in potential energy are negligible, we can get rid of these terms. Vi is given as 0. Thus final equation is hi is equal to he plus half ve square. Okay, it's a very simple problem. So inlet conditions, let me just increase the font. Okay, options, preferences, display, Courier. Okay, so the initial conditions, pi is equal to 200 kilopascal, Ti is equal to 400 Kelvin, well I is equal to 0. The exit conditions are Pe is equal to 100 kilopascal, Te is equal to 330 Kelvin, and we have to find out the exit velocity. So let me save this in the appropriate chapter, which happens to be this. So this is problem 6.30. 6:30. Okay. hi plus half multiplied by, okay, so vi square is equal to 0 equal to he plus half multiplied by v fell at exit square. Because I have already defined velocity at inlet to be 0, there is no harm in writing this down. Okay, so this expression should yield us the unknown, which is vel E. Okay, to find out the properties hi, we call the enthalpy function enthalpy of nitrogen T equal to Ti, P equal to Ti. Similarly, at the exit conditions, the enthalpy of nitrogen T equal to Te, P equal to Pe, because it is given that the fluid is nitrogen. Okay, so let's see. We have made a very big blunder, because hi blunder is as follows. Units of hi are in kilojoule per kg. Units of velocity squared will be in joule per kg. Thus, to make it consistent, we have to divide everything by 1000. If I divide it by 1000, the unit of this quantity will become automatically in kilojoule. This quantity is in kilojoule, this quantity is kilojoule. Okay, we have to keep this in mind. Half velocity square is in joule per kg. If I divide joule per kg by 1000, I will obtain kilojoule per kg, which makes the unit of he and half velocity square by 1000 equal. It's a very important thing to note, otherwise the answer will be wrong. So the velocity at exit is obtained as 389.5 meters per second, which is not exactly negligible. Okay, this is the solution. Okay, so the velocity at exit is equal to 389.5 meters per second. The sonic velocity is close to, this is approximately 1/3 Mach, which is not a negligible velocity. So the important concept of this question was that we should not neglect the exit velocity, because it is asked what is the exit velocity. We should always remember to make all the units consistent. The units of the enthalpy, specific enthalpy in this case kilojoule per kg, and the unit of half velocity square must be made appropriate. Okay, alright.